The Earth is warming at an unprecedented rate. This is not a drill, it is a wake-up call for humanity. It is the stark reality of our times, driven by human activity and the relentless release of greenhouse gases into our atmosphere. The consequences are already upon us. Rising sea levels, extreme weather events, and disruptions to ecosystems worldwide. Our planet's delicate balance is being thrown into chaos. The scientific consensus is clear. We need to act fast to avert catastrophic climate change. The window for meaningful action is rapidly closing. While reducing our carbon emissions remains paramount, scientists and policymakers are increasingly looking at other options to mitigate the damage. What if we could find ways to directly counteract the effects of global warming? Could technology offer us a lifeline? This is where geoengineering comes in, a set of technologies that aim to deliberately alter the Earth's climate system to counteract global warming. Geoengineering is not a new concept, but it has long been relegated to the fringes of climate science, considered too radical or even dangerous by many experts. However, as the urgency of the climate crisis grows, so too does the interest in exploring every possible solution, no matter how unconventional. Could geoengineering be part of the answer to our climate woes, or will it lead to unintended and potentially disastrous consequences that we cannot foresee? Geoengineering encompasses a range of ideas, from capturing carbon dioxide from the atmosphere to reflecting sunlight back into space. Some proposals involve manipulating natural processes, while others border on science fiction. One such idea, and the focus of this essay, is Marine Cloud Brightening, or MCB. MCB is a form of solar radiation management, a type of geoengineering that aims to cool the planet by reducing the amount of sunlight that reaches the Earth's surface. The basic principle is simple. By increasing the reflectivity of clouds, we can reflect more sunlight back into space, thereby offsetting some of the warming caused by greenhouse gases. While the concept might seem straightforward, the reality is far more complex. The Earth's climate system is incredibly intricate, and any attempt to manipulate it carries inherent risks and uncertainties. A marine cloud brightening focuses on low-lying clouds over the ocean. These clouds play a crucial role in regulating the Earth's temperature. By injecting tiny particles of sea salt into these clouds, scientists believe they can increase the number and size of water droplets within them. This would make the clouds brighter and more reflective, reflecting more sunlight back into space. The science behind MCB is based on the Toomey effect, named after physicist Sean Toomey, who first described the phenomenon in the 1990s. The idea is that smaller water droplets in clouds scatter sunlight more effectively, making the clouds appear brighter. By increasing the number of these droplets, MCB aims to enhance this natural cooling effect. However, critics argue that the science is still too uncertain. They point out that clouds are constantly changing and interacting with other atmospheric processes. Manipulating them on a large scale could have unforeseen and potentially harmful consequences. Despite the uncertainties, the potential of MCB to combat climate change has not gone unnoticed. In a bold move, the United Kingdom has decided to invest heavily in researching this controversial technology. The UK's Advanced Research and Invention Agency, or ARIA, a government body tasked with funding high-risk, high-reward research, has allocated a substantial £57 million, approximately $70 million, to a multi-year research project on MCB. This ambitious project marks a significant step forward in the field of geoengineering research. It is one of the largest investments in MCB to date and reflects a growing acceptance that we need to explore every option to address the climate crisis. The UK's decision to fund MCB research has been met with mixed reactions. Some applaud the government for taking a proactive stance on climate change, while others criticize the move as reckless and potentially dangerous. Section 5, From Lab to Sky, the experiment begins. The ARIA-funded project, led by a consortium of UK universities and research institutions, will involve a series of carefully controlled experiments, both indoors and outdoors. The initial phase will focus on laboratory-based simulations, using sophisticated computer models to better understand the complex interactions between clouds, aerosols, and sunlight. This will be followed by small-scale outdoor trials, planned for 2027 to 2028, off the coast of the UK. These trials will involve releasing small amounts of sea salt particles into the atmosphere using specialized equipment installed on ships or platforms. The researchers will then carefully monitor the effects on cloud formation and reflectivity using a range of instruments. These early experiments will be crucial in determining whether MCB is a viable option for combating climate change. They will also provide valuable data to assess the potential risks and benefits of this controversial technology. Section 6. The urgency of real-world testing. Professor Mark Symes, a climate scientist at the University of Leeds and one of the lead researchers on the ARIA project, argues that real-world experiments are essential to fully understand the potential of marine cloud brightening. He believes that without these practical tests, our knowledge will remain incomplete and theoretical. We can model these processes in the lab and on computers, he says, but ultimately, we need to see how they play out in the real world. Simulations can only take us so far. Real-world conditions are far more complex and unpredictable. Symes emphasizes that the UK project will be conducted with the utmost caution and transparency. Every step will be meticulously planned and monitored to ensure safety and accuracy. We're not talking about deploying this technology on a large scale anytime soon, he explains. The focus is on small, controlled experiments to gather crucial data. These are early-stage experiments designed to gather data and improve our understanding of marine cloud brightening. The information collected will be invaluable for future research and development. Despite the assurances, the prospect of deliberately manipulating the Earth's climate system makes many people uneasy. The ethical and environmental implications are significant and cannot be ignored. Critics argue that we simply don't know enough about the potential consequences of marine cloud brightening, and that even small-scale experiments could have unintended and potentially harmful effects. They stress the need for thorough risk assessments and public consultations before proceeding. Section 7. Doubts and concerns linger. Mike Hume, professor of human geography at the University of Cambridge, is a vocal critic of geoengineering. He has been outspoken about the potential pitfalls and ethical concerns surrounding these technologies. He argues that focusing on technological fixes like marine cloud brightening distracts from the root cause of climate change, which is our reliance on fossil fuels. Hume believes that these technological solutions are merely a band-aid on a much larger problem. It's a dangerous distraction, he warns. By diverting attention and resources, we risk neglecting the fundamental changes needed to address climate change effectively. Instead of addressing the systemic issues driving climate change, we're putting our faith in unproven and potentially risky technologies. Hume emphasizes that these technologies could have unforeseen consequences that might exacerbate the problem. Dr. Naomi Vaughan, a climate scientist at the University of East Anglia, shares Hume's concerns about the potential risks of marine cloud brightening. She has conducted extensive research on the subject. She points out that altering cloud cover in one part of the world could have knock-on effects elsewhere. These changes could disrupt weather patterns and ecosystems in unpredictable ways. The climate system is interconnected, she explains. Any intervention in one area can lead to a cascade of effects in other regions. What we do in one place can have ripple effects across the globe. This interconnectedness makes it difficult to predict the full impact of geoengineering efforts. These concerns are echoed by environmental groups, who argue that marine cloud brightening is a dangerous gamble with unpredictable consequences. They stress the importance of precaution and thorough research before implementing such technologies. They call for a greater focus on reducing greenhouse gas emissions and investing in proven climate solutions like renewable energy and energy efficiency. By prioritizing these measures, we can address the root causes of climate change more effectively and sustainably. Section 8. Exploring other options. While marine cloud brightening is currently in the spotlight, it is just one of many geoengineering ideas being explored. Other proposals include stratospheric aerosol injection, which involves injecting reflective particles into the stratosphere to mimic the cooling effect of volcanic eruptions. Direct air capture, using machines to remove carbon dioxide directly from the atmosphere. And ocean fertilization, adding nutrients to the ocean to stimulate phytoplankton growth, which absorb carbon dioxide. Each of these ideas comes with its own set of risks and benefits, and none are without controversy. However, as the climate crisis intensifies, the debate over geoengineering is likely to become more urgent and contentious. It is important to note that geoengineering is not a silver bullet solution to climate change. Even if these technologies prove effective, they would only address the symptoms of the problem, not the underlying cause. Section 9. A climate of uncertainty. The UK's decision to fund research into marine cloud brightening highlights the growing sense of urgency surrounding climate change. As the planet continues to warm and the impacts become more severe, the pressure to find solutions, even controversial ones, will only increase. Whether marine cloud brightening will prove to be a viable option remains to be seen. The upcoming experiments will provide crucial data to assess its effectiveness and potential risks. However, the debate over geoengineering is about more than just science. It raises fundamental questions about our relationship with the planet and the ethics of manipulating the climate system. As we navigate the uncertain waters of the climate crisis, one thing is clear: the decisions we make today will have profound